In this video, we're going to be discussing the ambiguous case for side-side angle triangles, or some of you know these as angle side-side triangles. Either one is fine, just reversing the order there. However way you want to remember that you must check for 0, 1, or 2 solutions for those side-side angle or angle side-side triangles. So the other ones you don't need to do that for, but these ones you do, and I'm going to give you a little instruction here on why in the heck you would need to check for 0, 1, or 2 solutions. So let's look at one possibility here, and I'll draw you a quick diagram, and I apologize if my lines aren't exactly straight. If you look at the downloaded notes, I was able to use a ruler for those. Let's label this A, and let's label this B, and then let's see here, this will be C over there. And then we'll label our sides being opposite of those. And one thing that we want to think about when we're looking at this example is that this angle right here, angle A, that can be the angle A here, and then side-side. So let's see here, we've got angle, side, side, or side-side angle. So A, C, and A in this case are static. We know what they are, they cannot change. However, anything else can change. So this side length here, B, could change. This angle B here could be different, and C could also change. But what we need to have static and in place is side-side angle. So A, C, and A here are the way they are, they're set, you can't change them. One thing that you might be noticing here is I've left a little bit of a gap, and so this is a case where this side length of the triangle, in maybe an example you've been given, you could change this angle, and so you could swing that side, kind of, you know. The side length itself can't change, but this angle B could change, but no matter how far we swing this thing, we could swing it all the way around, we will never touch this side, and we will never form a triangle. And so this is a case where there are no solutions, or we could say 0 solutions. It doesn't matter what you do with this angle B, or change the side length, or change angle C. This leg of the triangle here, the side of the triangle, is just too short. So it's not good for us. It's kind of the Goldilocks principle here, and this porridge is too hot. Let's take a look at another interesting example. And I'm going to make the leg the side of the triangle, excuse me, a little bit longer for this one. So we're going to have the same kind of setup here. We'll make it A, and that'll be B, and that'll be C over here. And I'm going to make this this side of the triangle here just a little longer. And let's see, this would be side C then, and that's side A, and this is side B. So what we can't change are angle A, that has to be set, and the side length C, and the side length A. That's our side-side angle, or angle side-side. The rest of them you can change though. You can adjust this angle B, we don't know what it is, and the side length B, and then angle C. So if we take a look at this, if we change angle B, and you'll wind up kind of swinging the side there, that side will form a triangle here, and it will form a triangle here. So there's really 2 possibilities for this one. I can say 2 solutions are possible because we don't know what angle B is, and it could change. And you can see in either one of these triangles here, we have angle side-side, angle side-side, and then this distance here, which is A, is the same as this distance A. So you could wind up with a triangle here where we have an obtuse angle, and then you could also end up with this bigger triangle here, and this angle is acute. Now I want you to take a look at these 2 angles, and we'll use this differently. So let's call this the measure of angle 1 here, and let's call this the measure of angle 2. You'll notice that these 2 angles here are exactly the same, and if you look at the first possible angle, so the measure of angle 1 here, and you add the measure of angle 2, they form a straight line, and they will no matter what situation you have. So measure of angle 1 plus the measure of angle 2 is going to be 180 degrees. And so this would be like the first case here, this triangle, and then if you can find that one, then you know that the second possible triangle those two angles from the first and the second possible must add up to 180 degrees, and we'll use that later when we solve these. I have two more examples for you so that you can see why we would want to even check here. We've done no solution or zero solutions and two solutions. So let me give you a triangle here where we're only going to have one solution. Then I'll give you another one where we only have one solution. Let's see if I can draw this well. We're going to go like this. We're going to make this side nice and long. So we'll keep the naming convention here the same. We'll just go angle A, which is set. So that'll be side A, and that's going to be set. And this will be side C, angle B. And so we'll fill in our triangle as we have there. And so this angle B can change, just like the other ones. We could swing this leg all the way around. But when we swing that leg all the way around, something interesting will happen here. So it's kind of long. Is it's not going to contact this side length B on the other side. It just swings right past it, and we would be able to swing it around, and we would keep winding up hitting right here in one spot. So there is a case where if this side of the triangle is fairly long, that it won't make it back, over here like this other one. It won't hit that side B. It'll go kind of right by it. And so this is a case where we only have one solution. So that is possible. There's one other possible, and I said Goldilocks before here, and this is kind of the Goldilocks, I guess, of side angle. So this is a side length that is kind of just right. And if we take a look at another triangle, let's draw this one here. We'll make this C there. And that point can move back and forth, so we'll just see how that works here in a second. So we've got A, B, and C. And then this would be side B, this would be side C, this would be A. And there's a case where the side A here, which we can't change its length, it's just right. So it just kind of hits right here, the side B. And you can see if you swing it one way or the other, this angle can be different. It's just AC and angle A here that are set. We meet at a right angle, and so it's possible that this is also something that we'll end up with one solution for the side angle triangles. It's kind of just right. Swing it up, it doesn't hit, hits once, and then we don't hit twice like we did up here. So you can see through these diagrams that you can have either no solutions, you could have one solution in a couple different ways, or you could have two solutions. And we'll just need to check those. And one big concept is that if there are two solutions, if you can find that angle here in the first one, the other one will add to 180 degrees. They're supplementary.